Thank you. Mr. Ashutosh Bhoi is presently working as an assistant professor in the Department of Computer Science and Engineering, Government College of Engineering, Kalahandi, Bhawanipatna. Mr. Bhoi completed his MTech from IIIT Bhubaneswar. He is about to complete his PhD in Department of CSC, IIIT Bhubaneswar. His research interest includes natural language processing, machine learning, and Internet of Things. He has published his research works in reputed journals like Elsevier, Springer, and PeerJ, etc. He has qualified GATE, NET, and JRF multiple times. He has successfully completed a research project sponsored by MHRD, Government of India. Now, sir,
Thank you.
You can continue, sir.
Professor Chinmay. Is my audible?
Yes, sir.
Is my screen visible?
Yes, sir.
Okay, thank you. So thank you, the team SOAWAL, for inviting me for this technical talk. And my topic for this talk is role of social media test for disaster management. Presently, I am working as an assistant professor in Department of CSC, GC Bhawanipatna. So the outlines of this seminar or talk is, it contains the introduction to social media text, then various applications of social media text, then how social media text can be helpful for disaster management, then the challenges associated with social media text analysis, then we'll discuss a solution pipeline, then we'll conclude the things, and finally the references. So, introduction. In this 21st century, this social media is a biggest buzzword, and it has become a part of our life. In each and every moment of our life, day-to-day life, we are using social media. If there is any few times with us, we certainly look for the different social media applications like Facebook, Twitter, or Snapchat, and all these things. So due to the wide usage of this microblog platform, so it generates huge volume of real-time data. So these data are real-time. So we every time we keep on sharing some details, sharing some information, our day-to-day life. So during disaster, so it's due to this huge volume of real-time data, so if we can properly analyze this data and extract the meaningful information, then we can use those data for numerous applications. So there are different applications of social media text. We can use it in the field of business. That means you can use for marketing. So if means launch a product, then we can give information about this, and people write their opinion about this product. And it also used for this sentiment analysis, recommended system. Then politics also, it can be means it is widely used. Recently in US election, last time, the Twitter plays a vital role. Then in education also, it can be an interesting application. In tourism, so whenever we move to a particular destination, or then before that we see about that particular location, what are the different places, and all this, we go through different blogs related to that. It also, it can be applied in healthcare sector also. And along with this, one of the interesting application may be the disaster management. So how social media text will be useful for disaster management? So before any disaster happens, if we get the information, if we can predict the disaster, then we can inform the citizens or all the people in that particular location about the disaster. We can broadcast that message. That is for a prior pre-disaster situation. And for if there is a disaster happens, then it can be used for post-disaster relief operations. And here in this talk we'll focus on the post-disaster relief operations. How this social media data or social media text will be useful for post-disaster relief operations. So for any post-disaster relief operation, resource mobilization is a challenging task. So for any post-disaster relief operation, we have to find out in which location or in which area what kind of resources are required or which kind of resources are available in that particular location. So if we can get those information, then it will be helpful for us or those who will be working in the disaster management organization which are working. It will be helpful for them to take quick and accurate decisions, so that proper mobilization of resources can be done. So if any resources is required at any particular location, those particular resources will be sent to that particular location, not every resources, or we may send some resources to some location where it is not required, and where in some other location there may be shortage of that particular resources. So that is the objective. So for this task, it highly depends upon the information gathering process. So the information gathering may be done in the traditional methods. That means we can talk to the affected people about their requirement in that particular location, or you may go there and take interview and all these things. But that is a tedious process, and we cannot cover everywhere. So for this social media, another approach is through social media. So whenever any disaster happen or any crisis event happen, the usage of social media increases. We tend to post about our situational things. That means whether we are safe or not, whether there is any shortage of any particular resources like food, water, shelter, medicine, medical staff, your infrastructure, all these clothes, these are the resources which are normally we require during any disaster situation. So people may seek for those particular resources through their post. So for analyzing the data, analyzing these real-time data, there are some challenges. First challenge is it is unstructured. These data are totally unstructured. That means if it is a structured data, then we can easily apply some SQL query to extract the information from them. So it is unstructured. Second one is it is complex and noisy. So complex and noisy means whenever we write something in social media or microblog sites, we are least bothered about the spelling and grammatical errors and all these things. So there are numerous misspellings are there, just like few examples are there. So there may be phonetics. Whenever you write something in microblogging sites, we use phonetic substitution, just like 4M. So actually it means from. So we regularly use shortenings like FWD for forward, then acronyms, that is NM, which means not much. Then we emphasize some words just like no, and so many O's are there, but actually it means to no. Then punctuations are there. We are least bothered about all these things. So normally whatever text analysis system are there, those works well with traditional our neutral text. That means they are perfectly fine with the grammatical and everything is fine. There is no misspelling, there is no phonetic substitution, there is no shortenings kind of things. Everything it is written correctly. It is correctly written. That is newspaper text. That means the text which is written in newspaper, that is totally correct language is there. So the traditional or the available systems which are there, they work very well with these new text. But whenever you apply those systems, state of the art system on microblock text, it doesn't perform like that. Another problem with this social media text is, or the microblogging text is, they are short in nature. Normally, whenever people are working on this area, they are using the Twitter data, because the Twitter data they can easily use, because with their APIs are available, through which we can through their streaming APIs we can scrap those data. So, but for other Facebook and other, it is not that easy. So those who are working, most people who are working in this domain, they are using the tweets. And for tweet, it is short in nature. Earlier it was 140 characters. Now they have increased it to around 280 characters. And still it is not that we have not that the length is not enough. So we have to write in brief. So if the text is, the nature of the text is short, then we cannot apply the traditional supervised learning. It doesn't work directly on the available supervised learning. So the solution pipeline for all the, so we have to first crawl the tweets from the Twitter sites. Then we have to do the reprocessing of tweets. Reprocessing means we have to overcome all these misspelling, the phonetic substitution, the punctuation. Then if there is hypertext is there, we have to remove all these things. Then we have to do and all these pre-processing and all these things we can use the NLTK library available in Python. So for that we can do the pre-processing things. And those who want to do some further research also, they can work on this also. Then the lexical normalization of tweets. Lexical normalization, that misspelling and all these kind of words, we have to bring those words to their correct form. So there are people have worked on this area also. So we can do in this also, or those system which are available, we can use them in the pipeline also. So basically they use normally the most popular one is the edit distance method. So you compare that particular misspelled word with available words in the dictionary or in a corpus, and which are close to that word we can substitute, and which has a minimum edit distance, so we can substitute that word. And this is one mechanism. There are other mechanisms are also there for this lexical normalization. Then the next one is extracting the name entities. So what is this name entities? Name entities are the basically whenever in any document or text, those words which are the person name or organization name, location name, all these are normally termed as the named entities. These are name of a person, name of a location, or name of an organization. So for our task, these disaster resource mobilization, this name entity plays an important role, and out of those name entities, the location entities is important. So for that also, works are there. People have worked on extracting the name entities, and we can use that in our pipeline, or we can work on that so that we can develop a new model which can extract the name entities in a better way. Then once the name entities, another next thing is taking up tweets with human annotators. So initially during the training, we need the train data. Train data means it is the label data. So if for each tweet we should have the particular have the label such as need tweet or available tweet or any labeling as per our requirement we can do. For disaster resource mobilization, normally we can classify them or label them as need tweet or available tweet. Where need tweet means where a person has written something that something is we required some particular resource like food, shelter, water kind of thing are available to it, means they have mentioned that that particular resource is available there. For the time being, they don't need that resource kind of thing. So, but the problem is that with that, if somebody may write we need water, then we may consider it as a need to it. But if somebody has written there is no availability of water, so here the word available is there, but still it must be mapped to a need to it, because there is no availability of water. So the context of that in any NLP applications, the context is very important. So we have to extract the context. So the better we extract the context, our performance will be better. So this is the challenge. And after that, calculating the feature matrix of tweet set. So this is very important. So as we know, for any machine learning model or any deep learning model, we cannot directly feed the text corpora into it. So all these models, mathematical models, works on numerical data. So if we are working in image processing or kind of thing, at that time we are giving the feature matrix. We are giving the feature matrix, and whenever we get the data, normally we get the means matrix directly. Or if you are working on gene expression data, so here also the data are in numeric form, in matrix form. But for this text data, we have to convert them. We have to convert them to their numeric form, numerical data. So this is the challenge, and most of the contribution we can do in this part, and most of the research is going on in this part. And the in industry also people are working on this. They are developing new systems, and recently few systems are like the popular system that is in what to bag or globe kind of things, or bot are there. So we'll discuss that. So the heart of this pipeline is that calculating the feature matrix. If the feature matrix is good enough, then our performance of that our system will be better, will be good. And if the feature matrix is not good enough, then the performance will be poor, or it may be moderate. So the most maximum focus or maximum contribution we can do in this part. After that, once the feature matrix is generated, we can do the classification, ranking, and mapping of tweets. So in classification, first we can once the tweets are extracted, so we can classify them whether it is a new tweet or availability tweet. So before classifying them as new tweet or availability tweet, whenever we means scape the things in at that time, some non-disaster tweet may also be there. So in that case, we have to first filter them out. So that is also means a classification problem, whether it is a disaster tweet or non-disaster tweet. So during a disaster tweet, suppose few tweets are there where there is no mention of any resources. That means it is a traditional twins, one disaster has happened in this particular location kind of thing, or something like that, where there is no mention of any resources or any need of resources or availability of resources. Then we may call them as irrelevant tweets. So we may classify if something is disaster related to disaster, but which are not relevant to our problem. So for that, again in the second step, we may another classification task whether it is relevant to our problem or not. We can classify that. So we are classifying these before, prior to that, because so that whenever we classify as need or availability, at that time the accuracy will be better. Otherwise, if these errors will be there, then our accuracy will decrease. So once classification is done, then the ranking is another task. So in ranking, ultimately our objective is we have to map the need tweet to the availability tweet, and we cannot map every need tweet to every availability tweet. So based on the priority, we can rank the tweets, need tweets, and there are some works are there in ranking, but there is not that much sufficient works are there in ranking. Few works are there. Unlike classification, there are so many works are there in classification, but for ranking, very few works are there. And one of the popularly used one is your learning to rank. It is developed by Google. Okay, that one is for the timing, that is very good. And after the ranking, that means we can rank the tweet based on its priority. Where if something is some person has mentioned about requirement of urgent requirement of any medical doctor or medicine kind of thing, so its priority is more. So in the ranking means ranking step, it must be above, it must be above, and based on the priority we can rank the tweets. And once all the tweets are ranked based on their means priority, after that we can do the we can map them to their corresponding availability tweets, to their corresponding availability. These are the basic problems, or the whenever you want to solve these uh, disaster resource mobilization problems, these three are the means benchmark tasks, that is classification, ranking, and mapping. And for good performance of all these tasks, the feature, the generation of feature matrix is extremely important. So, so for representation of text, there are initially one hot vector representation was used for the NLP problem. That means for any for in a corpus, all the distinct word will be a column, and in a particular sentence, or in our case here in particular tweet, if that particular word is there, then it will be 1, otherwise rest of the word will be 0. So here it it informs that whether that particular word is there in that tweet or not. So here the problem of this is there is no information of context. So in any means all these text data, the data are in sequential form. So the meaning of a particular word mostly depend upon their preceding words, which are their prior information is extremely important. So this prior information is called as contextual information, and in one hot vector representation there is no contextual information. Then another one people use is TF-IDF based representation, that is term frequency inverse document frequency. That means if any in any document or in any sentence, if a word is there in that document, then if one word is occurred multiple times or numerous times, then that may be considered as a its importance in that particular document is more. Some words which are occurring frequently, then we may means expect that its importance is more. But on the other hand, if some words are there which has occurred frequently, then it should not have that much of significance also. So just like in one document, some words and the a and the kind of just normal words are there, that where all these words in everywhere every document we can find all these words frequently. So if such words which are means frequently occurring, then its their significance may be less. So that's why the term frequency and inverse document frequency, that is a what means only term frequency cannot be that much meaningful. So we consider both term frequency and inverse document frequency based representation. And it has also the same problem that it takes the word based features. That means the contextual information is not there in this representation. So that's so people move to this embedding based representation. Next, people move to the embedding based representation. In embedding based representation, there are word embedding, character embedding, sentence embedding. So here this embedding is also a vector. That means each word will be a vector. So for which will arrange all these words, then it can be a matrix. It can be a matrix, and after that, that particular matrix, which is in numeric form, that can be fed to the any machine learning model or deep learning model, so that the model will work on this numeric data and do our task, any task like classification or prediction or our clustering or here ranking or mapping. All these tasks can be done. So this embedding is nothing but a vector. And why we need this vector? Because we want to convert the word to their corresponding numeric form, so that the numeric data will be given as input to the machine learning or deep learning web models. So what are the available tools for these representing the or converting the textual information or textual corpus to their embeddings or vectors? The most one of the most popularly used word to vec. It is developed by Google, and in the TensorFlow library it is there. Similarly, and this word to vec is a neural network based model. So there is another tool is Globe, that is your global vector for word representation. And another recently developed one is working well. So here is a comparison based on my experience. So this TF-IDF, this is a statistical method to capture the relevance of words with respect to the corpus of text. It does not capture the semantic word association. That means it gives the information about that particular word. It doesn't have any information about the preceding words or succeeding words. So it is a better for information retrieval and keyword extraction in documents. Okay. Then second one, that what to get. This is neural network based continuous bag of word and scriptgram architectures, and it is better at capturing semantic information because it contains the contextual information or semantic information. It is useful in semantic analysis tasks. Then the third one is, as I said, that is a global. That is a global vector for word representation. It's developed on matrix factorization based on global word-to-word co-occurrence. So it solves the local context limitation of word-to-vec, and this will work well better at word analogy and name entity recognition tasks, and comparable results with word-to-vec in some semantic analysis tasks, while better in others. So normally for Twitter means tweets data, the Globe works well. What to vec. Okay, and the last one is the bot, and it is a transformer-based attention mechanism to capture high-quality contextual information, and it works well on language translation models or question answering systems, and it is developed in Google search engine to understand the search queries. So these are the popular representation techniques available for converting the text to their corresponding numeric forms. So what are the available disaster tweet data set? One is the fire Nepal earthquake data set, and it is fire is your forum for information retrieval and evaluation. It is one of the what active forum in India who people are working in the field of natural language processing and information retrieval. Most of the top researchers in India are associated with this forum, and they have developed one data set which is based on the Nepal earthquake which happened in 2014, I think, and they have they gave this data set in 2015 or 16. Then another one is your crisis lex. There is crisis lexicon, it is a corpus, and there are so many data sets are there. There's crisis lex T6, crisis lex T26, and there Chile earthquake and Sandy storm. There are different other are also there. So here in crisis lex T6 is, that means it contains information about 6 different crises, and in this crisis lex T26 it contains information about 26 different disaster. It may be earthquake, it may be flood, it may be storm, different thing. Then this SMERP, that is your social media for emergency relief and preparedness. This is also another data set, and people are using this data set also very widely. And this fire and Nepal earthquake data set is related to this one. On this with this kind of approach, they have developed this fire Nepal earthquake data set. And another, we can find some other data set in GitHub also, that natural hazards Twitter data set. There are different data sets in GitHub also. So we can use this data set if we want to do any research in this field. Then we can use this data set because people are widely using these data sets. Then whenever you develop some system in this, so different performance metrics we can use. For classification task, we can use precision, recall, F1 measure kind of thing. So these are the formula, and it is known to most of you. And if for a ranking task, we may use the p at the rate k matrix, that is precision at the rate k. So whenever we rank something, and if you are ranking top 3 or top 5 tweets, and out of those 3 tweets or 5 tweets, how many are correctly ranked? If some human will go through all the tweets, and he or she, human annotator, will rank the tweets and what the system is giving. Based on that, if that p at the rate k can be used for that ranking task. And for mapping also, we can use the accuracy kind of thing. So different performance metrics people can use. Then we can conclude the talk. That means here in this talk, we can that disaster management, we discussed about disaster management using social media text. Is that means it is becoming a hot research topic. So people have started doing the research in this domain recently, and there is a long way to go. So as there are numerous challenges associated with this microblock text, as we discussed, it is totally different from news word text. That means those systems which are available and they are working very well in news word text or our traditional NLP applications, they are not working up to the mark with this microblock text, because so much peculiarity is there with this text. There are so many grammatical errors, so many misspelling, punctuation, there is hypertext, there is a link, anything can be there in that text. We are totally least bothered about the grammatical correctness or the correct spelling of any word, and they don't follow any pattern. Just like in our traditional English, that means subject, object, verb kind of thing. They follow a particular part of speech, but these microblock text, they don't follow such thing. There is so much peculiarity. And another thing, another challenge is that whenever we write something in microblog like tweets or Facebook post, we try to combine different languages. We try to combine different languages in a post. There may be few words in English, few other words maybe in our native language, kind of thing. So it is called code mixed tweets. So that is another challenge. So if such situation happen, then that is one extreme challenge. So first we have to convert them to any particular means any particular language. So if there is a combination of English and Hindi, then we can convert those Hindi words to their equivalent English word, and after that we can use this technique. But every time, for that means how much the translation will be successful, the system performance depends on that also. And if people use some native language like Odia or some other Bengali kind of things in that tweet, then it is still more challenge or more problematic for the researcher. So this is one of the biggest issue with it. So with this challenge, if we work and if we can develop a robust disaster management system, which can develop means then it will be a great help for disaster management organization. That means with the help of that particular system, those organizations which will work for post disaster relief operations, they can decide that which area should be given more focus, or what kind of resources may be given to that particular location, and based on the requirement. So, and all these things can be done with the proper disaster management system, and for all this, the proper analysis of the microblog data or any social media text is very much important. And these are the reference I prepared my slides based on the papers. There are so many. This first one is a survey paper. People have means it has captured many, or it has included many works, and the other two are my works which are published recently. And these are the links which I have gone through for preparing the slides. And people may follow these means sites or these pages to go through all these popular tools, so that they can use these tools to work, do their research in this area. Because whenever if there is available tools are there, it is always better to use them. Okay, so that the task will be easier and do some contribution in some particular aspects. So thank you, and it's all from my side, and I expect some questions. Okay, please. So there are all these models are there. Each have their strength, and each are developed with some particular applications in mind. So if our traditional text, normally word to vec works fine. Our traditional text or newswire text kind of thing. So, but if it is just work on social media text, then the context is important. And in those cases, we can use this Globe and this bot. And all these are pre-trained model. So all these are pre-trained model. They have trained their model, and based on their means training data, we will feed our data, and it will give us the vectors, equivalent vector representation for that particular for those particular text. So normally, I suggest if someone is working in microblogging text, then it is better to use this global vector or this bot. And recently, people found success in bot also, because it is in bidirectional uh, aspects. Yes, yes. That means after this representation, we can use our machine learning models, just like any classifiers, like any classifiers means traditional classifier like SBM or decision tree or our KNN, anything, or multinomial name base, all these are there. Or we can use our deep learning model like LSTM or CNN, or we may combine. People are working on the combination of these deep learning models. So after the representation, all these classifiers or any clustering algorithms will comes into the play. So before that, we have to represent the things.
Uh,
Thank you. Anyone, please?
Ma'am, is my voice audible to you? I have a few questions. First of all, thank you, Ashutosh sir, for the informative presentation.
Thank you. Thank you.
I have few questions related to API only.
Yes, please.
Yeah. So, is this work which you have done or might be completing, going to be completed? May I know exactly, can it be work in real time data?
Yes, yes, it will work. It will work. It will work in the real time data. But if we have at the training time, we need some human annotators. We need the help of human annotators. But whenever we deploy it in the system, at that time new data will come, and it will directly go to the means feature representation model, or after that the other task based model, that is classification, ranking, or mapping models.
Okay.
So at the training time, we need the help of human annotators, because we need the label data. That means whether that particular tweet is a need tweet or availability tweet kind of thing. So based on that, with those data, we have to learn the model, learn any classifiers. All these means labeling is required for our that classification task, any supervised learning based task or model. And if you are not using any, if you are not using the supervised model or unsupervised model like a deep learning model, it can directly means what means.
Yeah, thank you. But another one question is that
Please.
only Twitter based data that you are going to analyze, or any type of data which is considered as information? Are you taking that type of information and can you convert that?
I have used the Twitter data, and most of the people are using Twitter data, because Twitter provides the APIs to extract the data from their site. But this is that extraction of data from Facebook or any other microblogging sites is not that easy, because they have not given their APIs. But Twitter provides the API, so that people can extract the data from their sites based on the keyword search or some kind of search. So that's why people are using Twitter data. Most of the people are using Twitter data. Otherwise, if the data is with us, then we can work on Facebook post also, or any other kind of post also. But we don't have that much data, because we don't have the APIs.
Yes. Yeah. Thank you, sir.
Thank you. Anyone else, please? Okay, let's conclude. Thank you, Team SOAWAL, for giving me an opportunity to deliver it. Thank you. Okay, thank you.